now that we know how to graph sine and cosine, now let's look at the other four functions. All right, tan and cotan are probably just a little bit harder than secant, cosecant, so let's start with those. Okay, let's do tan the same way we started sine and cosine. We look at it on the unit circle, and we look at the points. Okay, so let me label these up. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. All right, now remember, tan is your y value over your x value. So if I go around the circle the same way I did with sine and cosine, I would get something like this. Tan of 0, y over x is 0. Tan of pi over 2. Okay, if I go y over x, would be undefined, so I get an asymptote. Okay, so whenever you have undefined on a graph, it means there's an asymptote. Excuse me. Tan of pi, 0 again. Tan of 3 pi over 2, asymptote. Tan 2 pi, 0 again. So if you look at it that way, you're really not getting a whole lot of the graph. All right, if we go in the negative direction, let's try the negative direction. So if I go negative pi over 2, all right, you get undefined again. So if I try to look at tan the exact way I did with sine and cosine, you're not really getting a whole lot. What that means is you're going to need more points. So now let's look at a point in the middle of all this. Let's look at pi over 4. Okay, now remember, pi over 4 is like 45 degrees. So if I were to draw pi over 4 in here, I would have a 45, 45, 90, which we label 1, 1, root 2. Okay, so if I say, what's tan pi over 4, you'd say it's 1 over 1, so tan pi over 4 is 1. So at least I have another point now. And if I do another one, if I do negative pi over 4, and I do the same thing, okay, so negative pi over 4 would be down here, with a negative 1 for the y value. So tan negative pi over 4 is negative 1. Sorry, that got a little messy. But if I look at these 3 points, and they're kind of bound by the 2 asymptotes, then I have tan looking like this. Now, a lot of students like to say that tan looks like a cubic function. And the overall shape, sure, it does look like a cubic function. But just as long as you know it's not exactly the same, because the points wouldn't match up exactly. Okay, so if you look at this, if you look from the left-hand asymptote to the right-hand asymptote, from negative pi over 2 to pi over 2, look at the period of tan. It's only pi. All right? So sine and cosine have period 2 pi. Tan has period only 1 pi. All right, now this one has 2 asymptotes. So we say they're at plus minus pi over 2, only 1 0 in the middle, and it's an odd function, so it has origin symmetry. Now, let's do the same thing with cotan. All right, so I draw in all the same points, 1 0, 0 1, negative 1 0, and 0 negative 1. Okay, now remember, cotan is the reciprocal of tan, so cotan is going to be the x value over the y value. Okay, let's do the exact same thing. Go around the circle, tan of 0, or sorry, cotan of 0, the x value of the y, that's undefined. So I go ahead and I get an asymptote right away. And then pi over 2, the x over the y is 0, and pi, another asymptote. Okay, and then it starts repeating itself, just like tangent did. So once again, we need more coordinates. So let's look again at pi over 4, 45, 45, 90. Cotan would be, so pi over 4 would be here. Cotan would be 1. All right? And since the asymptotes go to 0 to pi, let's look at another 45, 45, 90 over here. Whoops, 4. 1, negative 1. Cotan would be negative 1 at 3 pi over 4. All right, so if I swoop in what cotan looks like, it goes high to low and in between those 2 asymptotes. Now look again, period is pi, just like tan. Asymptotes are 0 and pi, and it has 1 0 right down the middle. Now, it is also an odd function, so if you rotated that about the origin, you'd get the same shape. Now, I want you guys to try number 1, because it's a little bit easier than number 2. So number 1, you're just taking the tan graph, the same tan graph, and all you're changing is the y-axis value. Instead of a 1, it becomes a 3. So if you graph 3 tan x, it should look almost identical, but with a 3 for the amplitude part, for the y-axis part. All right, and I want to do number 2 with you. All right, so this one's cotan. And this time, we have a 2x here. Okay, now remember how we do the period. You take the original period, which for cotan is 1 pi, not 2 pi like sine and cosine. So you take the original period, divide by the coefficient of x. Okay? So that means cotan, if I go ahead out here on my x-axis, put a pi over 2, this graph is going to have an asymptote on the y-axis, and then another one out here at pi over 2. So now I have to start cutting this graph in half. I'm going to cut it in pi over 4. And now if I cut a fourth in half, I get an eighth. And remember, they're all symmetrical. So 1/8, 2/8, 3/8, and then 4/8. Okay, so now I have it all labeled. Now cotan has a 0 right in the middle. If 4 is in front, it stretches up to 4 and negative 4. And then you have to remember that cotan starts up high and ends down low. There's my cotan graph. Okay, so the period for this one, pi over 2. Asymptotes at x equals 0 and pi over 2. And there's a 0 at pi over 4. Now kind of a funky one. Okay, so look at this one, tan pi x. All right, so the period, remember, is original period pi for tan divided by coefficient of x. Okay, so for this one, it's just 1. So that's kind of cool, because that means on my x-axis, I'm not going to have any pi's, just 1s and 1/2. Now, remember that tan has the y-axis right down the middle of it. So if the period is 1, that means I have to go left a half, right a half, and those will be my asymptotes. So from the left-hand asymptote to the right hand is a period of 1. So this whole distance is 1 unit. Okay, then if I cut that in half, now I'm in fourths. Okay, so tan has a 0 in the middle. This one just has a 1 in front of it, so just a 1 in the front and a negative 1 down here. And tan goes low to high. Okay, so this one has asymptotes at x equals plus minus a half with a 0 at 0. Since cosecant and secant are the reciprocals of sine and cosine, a nice way to approach these is to think about the sine graph. Okay, so here's the sine graph. Let's practice that again. So 2 pi, cut it in half. So sine graph starts like this, right, with an amplitude of 1. All right, so if you picture sine a minute, that's what sine looks like. Okay, and then you have to remember that cosecant is 1 over sine, or the reciprocal of sine, however you want to think about it. But what that means is, when sine is 0, okay, so sine is 0 here, 0, pi, and 2 pi. When I try to take the reciprocal of 0, or to put 1 over 0 for cosecant, all of those points turn into vertical asymptotes. So cosecant has 3 vertical asymptotes. Okay, and then if I do the same thing with a couple more points, so if I take the point at 1, right here, if I take the reciprocal of 1, so 1 over 1, that one kind of stays put, stays right here at 1. If I do the same thing with negative 1, stays put, 1 over 1. Okay, now let's look at another point. What if sine is a half, let's say? Okay, so I'm going to circle it here. So sine is a half. Well, think, what's the reciprocal of a half? It's 2. So cosecant has a point at 2. So anytime sine is a half, cosecant is 2. Anytime sine is negative a half, it's negative 2. So see all these big red dots? I'm trying to make them kind of bigger. Those are your cosecant points. And if you look at it, they're bound by the vertical asymptotes. So you have this kind of U shape here and upside down U down here. So there's your cosecant curve. And the period is 2 pi, just like sine. All right? It doesn't have zeros this time, it has asymptotes at 0 pi and 2 pi. There are no zeros, and it's still odd like sine is. Now, same deal for secant. If I picture cosine, okay, so here's cosine. Let's go ahead and graph it in real quick. All right, so cosine, and then you have to remember that cosine is your U shape. So cosine looks like this. All right, so there's my cosine. Now, anytime cosine is 0, secant should be undefined. So I should have an asymptote here at pi over 2, and another one over here at 3 pi over 2. All right, and then if I do the same kind of reciprocal idea, reciprocal of 1 is 1, reciprocal of a half is going to bump up to 2, reciprocal of negative 1 is negative 1, same thing with negative a half is negative 2, and then the same thing over here. Okay, so all these red points make up your secant curve. So it looks like this, upside down in the middle, and then toward the asymptote at the end. All right, now let's see what happens when you change the period of secant. So we know what the 2 in front, that's just going to change the y values, right? So on my y-axis, I can go ahead and just put a 2 there. All right, so that's what the 2 in front does. Now the 1/2 does the same thing it always does. This 1/2 is going to affect the period. So the period of this one is going to be your original period 2 pi over your coefficient of x, which is 4 pi. So before I start anything else, I'm going to go ahead and put 4 pi way out here. And then when I do my slicing in half, this one actually has pretty nice numbers. Okay, now remember, secant is the reciprocal of cosine. So you don't have to necessarily draw this in, but I will. Here's what cosine would look like. Right? Cosine would look like this. So again, this green, you don't need the green, but I just want to show you where it comes from. Okay, so if I take that green, okay, so every time there's a 0 on cosine, we're going to get a vertical asymptote on secant. So here we go. Vertical asymptote, and then all the cosine pieces are going to flip toward the asymptotes like this. So the black curve is your final answer. Okay, so the period of this one is 4 pi, and the 2 asymptotes are at x equals pi and 3 pi. All right, I'm going to do one more. I'm going to do number 5. It's a little bit tougher than 6, so then I'm going to have you guys try 6. Okay, the 2 in front of 5, no problem, right? That's just 2 times your y values. So I can go ahead and just put a 2 on my y-axis. Okay, this 2/3 of a pi, oh, you know what, I forgot an x when I type this. That should have an x. Okay, the 2/3 of a pi x, that affects your period. So the period is original period over coefficient of x. Okay, now when I do my flip and multiply on this one, look what happens. My 2 pi's go away, so my new period for this one is just 3. So when I start this graph, I'm going to put a 3 out there. And then I cut it in half, I get 3 halves. Cut that in half, I get 3/4. Okay, so 3/4, 6/4, 9/4 right here. Okay, now I have my x-axis labeled. So then I have to remember, if you don't want to draw sine in, you do not have to, but I'll go ahead and do it one more time on this video. So if I draw sine in on this graph, it would look like this, because cosecant and sine are reciprocals of one another. Okay, so this green is my sine curve. And if I take all of those points and flip it into cosecant, here's what we do. Okay, so wherever sine is 0, cosecant gets an asymptote. Okay, so there's my 3 asymptotes. And all these green pieces, they're going to flip toward the asymptotes. All right, so if I have to answer the box, I said the asymptotes are at x equals 0, 3 halves, and 3. All right, now please try number 6. Don't leave it blank. Please, everyone, give it a shot.